This video is on 5.2 Solving Quadratic Equations by Factoring, your favorite Algebra 1 topic. So we've got a bunch of different factoring rules that we are going to review from your Algebra 1 just in case you forgot. We're going to start by factoring out the GCF, and we know that the GCF is the greatest common factor. So what is the biggest number and or variable that you can pull out of each piece? What do they have in common? So when I look at the 6 and the 2, they share a factor of a 2. This one has 2 x's, that one has 1, so they also share a factor of an x. I'm going to take these pieces out. So 6 divided by 2 is 3. We had 2 x's, we took 1 away, we've got 1 left. We bring down our subtraction sign. 2 divided by 2 is 1. We took out that x, so I have a 1 left. If I start with 2 pieces, when I factor out my 2x, I should still have 2 pieces there on the inside, so don't forget that. When we look at number 2, we've got 3x squared minus 6x plus 9. We always check for GCF first, no matter what. And we look, we've got a 3, 6, 9. I can pull out a 3. Got 2 x's here, 1 there, no x's there. Therefore, they don't share any x's, so all I can pull out is a 3. 3 divided by 3 is 1x squared. Pull down that minus sign. 6 divided by 3 is 2x plus 3. 9 divided by 3 gives you your 3. Going on to number 3, we've got a, remember that's a 1. 1, negative 2, 5. There's no coefficients that can be pulled out. I've got 3 x's here, 2 there, 1 there. So they all share 1x. When I pull that out, I only have 2 x's left. I only have 1 x left in the middle, and no x's left on the end. Number 4. Number 4, anytime you see this crazy stuff going on when you've got all these variables with all these crazy exponents, the only thing that you can do is GCF. When we look here, there may be some more factoring I could do down the road, which we'll get to in a second. But once I look at this right here, I look at 5, 10, 2. I look for numbers that they all share, and there's none. Yes, 5 and 10 share, 10 and 2 share, but all 3 of them don't share any factors. So there's no coefficients I can pull out. X squared, x to the 12th, and x squared. The most amount of x's that I can pull out is 2. If I try pulling out more than 2, I'm going to come up to a problem in the first piece. So I'm going to pull out 2 x's, so I'm going to pull out an x squared. We've got y to the 10th, y, and y to the 5th. So I've got 10 there, 1 there, 5 there. So the most amount of y's I can pull out is 1. If I try pulling out more than 1, I'm going to come into a problem with the second piece because there's not enough to pull out more than 1. And then z, there's no z there, z squared. In this case, I can't pull out any z's. Remember, greatest common factor is what do they all have in common? Well, the middle piece doesn't have any z's in common, so there's no z's in the GCF. So we've got our 5. We pulled 2 x's out. We only had 2, so there's no x's left. I pulled one of those y's, so now I'm left with 9. And I didn't pull any z's, so that z's still there. Bring down your subtraction. We didn't pull any numbers out. We've got 12. We take 2 away. We've got 10 x's left. We had 1 y. We took it out, so there's no y's left. Plus 2. We took out both of those x's, so no x's. I had 5 y's, took 1 away. I've got 4 left. And I didn't pull any z's out. And that would be our answer. Difference of 2 squares. Hopefully you are going to rock at this. I know sometimes difference of 2 squares is so easy that it becomes hard. First thing about the name. If it's the difference, I need subtraction. If it's 2, yes, we need 2 of them, and we need perfect squares. And hopefully you remember perfect squares is anything that you can take the square root of and not have decimals. So we look here. Oh, we've got subtraction. 1x squared is a perfect square, and 4 is a perfect square. So the only way to get that middle term to cancel out is if one's a positive and one's a negative. So I've got x plus the square root of 4 is 2. So we've got x plus 2 and x minus 2. Just to prove this to you, and no, you do not have to do this, let's go ahead and FOIL this back out. That's x squared minus 2x plus 2x minus 4. Oh, look, a negative 2 and a positive 2. Gone. And that leaves us with the x squared minus 4. So the only way to get that middle term to cancel out is if everything's the same in your two pieces, but one's a plus and one's a minus. That causes those opposites to be created. When we look at number 6, we got 36x squared minus 25. First, we check for subtraction. Good. Second, we check for two perfect squares. 36x squared. That's a perfect square. 25, that's a perfect square. So we go to break up our two pieces. The square root of 36 is 6. The square root of x squared is x. So the first term there is a 6x. We need one positive, one negative. The square root of 5, or square root of 25 is 5. We look at number 7. And even though we didn't do it in 5 and 6, the first step of factoring, no matter what, is GCF. So we look and they do share a common number. That's 4. So I pull out that 4, and I'm left with 4 times x squared plus 4. There's a problem. What's our problem? Yes, we don't have subtraction. If we don't have subtraction, then we don't have difference of two squares. You must have a subtraction sign there, because if I were to multiply those two out, I would get a minus 4 the way I did here, not a plus 4. That's not possible. This is not difference of two squares. All you can do here is pull out the GCF. So the first thing you check for is GCF. No matter how many pieces, no matter what it looks like, that's step 1 of every single problem. Then, if you have two pieces, you check to see if it's a difference of two squares. Then the third thing that you're going to do is do regular factoring. Regular factoring is when our x squared term has a positive 1. So that's if there's no number with the x squared there. That's when we're going to do regular factoring. And for regular factoring, you multiply to the outside and you add to the middle. And again, I know this is all review for you. We're just going to refresh back up on our skills. So we've got x squared plus 8x minus 9. So again, we want two numbers that are going to multiply to the outside and add to the middle. Oh, before I do that, check for GCF. Oh, good, no GCF. So now we move on to regular factoring. I know I'm going to have my two pieces, and I know I'm going to have an x, and I'm going to have an x. I'm multiplying to a negative and I'm adding to a positive. If I'm multiplying to a negative and adding to a positive, I know that I'm going to have one positive number and one negative. That's the only way to get a product that is negative. If I want my sum to be positive, that means the bigger of the two numbers has to be positive. And that's going to be a 9 and a negative 1. You can always double check to make sure that you've met both criteria. So 9 times negative 1 is a negative 9. Good. We've got our multiplication. 9 minus 1 is 8. Good. You've met your middle piece. You don't have to write this on your paper, just kind of mentally check to make sure that you've hit both pieces. Alright, check for GCF, boom, nothing shared. So we're multiplying to the outside, adding to the middle, we break it down into our two pieces. We have a product of a negative again, so we know we're going to have one positive, one negative. This time our sum is negative. If our sum is negative, we know that the larger number is going to be negative. And that's going to be 7 and 5. And again, we can double check. 5 times a negative 7, negative 35. Good. 5 minus 7, negative 2. I've met both criteria. Moving on to number 10. 2x squared plus 26x plus 60. GCF, and we do have a GCF. I can pull out a 2. I'm left with x squared plus 13x plus 30. I just divide each of my pieces by 2 and keep that on the outside. Do not lose the GCF. You can't just divide by 2 and lose that greatest common factor. Then you're changing the value of it. So make sure that you just pull that out to the outside, and that's it. Alright, so now we are going to, again, multiply to the outside and add to the middle. Not losing the GCF, so that 2 is out there. And And we've got a positive product. So I have two options. They're both positive or they're both negative. Since my sum is positive, I know I'm going to have two positive numbers. And they happen to be 10 and 3. 10 times 3 is 30. 10 plus 3 is 13. So your complete factorization is 2 times x plus 10 times x plus 3, that whole thing. All right, moving on to some Batman factoring. Get ready for some fun. Okay, so Batman factoring is what we're going to do when we have an ax squared plus bx plus c. So this time we're not going to have a 1 with the x squared, even after I pull out GCF. Because if we look at number 10, yeah, our a was 2, but we were able to pull it out with a GCF, so that left me with a positive 1 coefficient. Even with a GCF, my first term's still not going to be a 1. If our first term's still not a 1, we've got to use this awesome method of Batman factoring. So we check for GCF, unfortunately not. We multiply the first number and the last number. 12 times the negative 7, we've got negative 84. Pull down your first term of 12x squared. Pull down your last term of a negative 7. And then let's make our picture a little bit prettier so you can see the Batman wings. Alright, so what we're going to do here, we're going to break down this 84. What we want are two numbers that are going to multiply to the negative 84 and add to the negative 25x. So we're looking for these numbers here, and those numbers happen to be a negative 28x and a positive 3. So negative 28 times 3 multiplies to a negative 84. Negative 28 plus 3 is a negative 25. Now we're going to factor by grouping. So we pull out the GCF, which is a 4x. And inside we're left with 3x minus 7. We look at the second piece. They don't have anything that they share, so the only thing that you can pull out is a positive 1. Make sure that you pull that number out, which leaves us with a 3x minus 7. Make sure that you have that same piece inside each of those quantities. If these two aren't the same, then you made a mistake. Take the two GCFs that you had taken out. That's going to create your first factor. Then, since those are exactly the same, that's going to be creating your second factor. And you're not going to do that twice. It's just going to be 3x minus 7 one time. And there's going to be your answer. What I want you to do is press pause. And at this step, I want you to switch where the 3x and the negative 28 were and see what you find. Alright, you see that when you switch where the middle pieces are, it does not make a difference. We pull out our 3x over here, we pull out a negative 7 over there. You still end up with the exact same two factors. Everything's just kind of switched around. So instead of the middle pieces being the 3x minus 7, those are now the GCFs, and vice versa. Alright, moving on. How do I know whether I factor or I solve? Well, you're always going to factor, but sometimes you factor and stop, and other times you factor and then use ZPP to solve. If there's an equal sign, then you use ZPP and solve. Now, in order to use ZPP, our zero product property, you must have it equal to 0. So we look at number 12. Awesome. It's already set equal to 0 there, so I know I'm going to solve. So I first start by factoring. I factor out the GCF. And then ZPP is setting each piece equal to 0. And then we get here that, oh, I'm running out of room here. We get that x is equal to 0. We move the 1 over. We've got 2x equals 1. And we get x is equal to 1/2. When we look at number 13, there is no equal 0. So there is no solving. There's just factoring. We start with the GCF. And then we're looking for two numbers that multiply to the outside and add to the middle. We have a positive product with a negative sum. So we've got minus minus, a 4, and a 2. And that's our answer, and we are finished.